The paper of the day is Transaction Management in the R-Star Distributed Database Management System. This paper describes how to handle transactions in a distributed environment using a two-phase commit protocol, or 2PC in short. 2PC is a form of atomic commit that uses a coordinator to decide whether or not to commit or abort a transaction. The paper goes on to compare standard 2PC with two variations, one presumed abort and presumed commit, which differ in how they handle failure conditions. This paper review will be divided into three sections, one for 2PC, one for PA, and one for PC. For the purposes of this discussion, all nodes are presumed to use a write-ahead log to provide support for recovery from failures at each node. The two-phase commit protocol divides each transaction into two phases. The first phase is the prepare phase, where each node participating in the transaction is sent a prepare message. Nodes respond to this message with a yes vote or a no vote, stating whether or not they are willing to commit the transaction. That is, that no lock conflicts exist. If all node votes are yes votes, the commit phase of the protocol is started. The coordinator first writes a commit log and then sends a commit message to each node participating in the transaction. Upon receipt of a commit message from the coordinator, each subordinate node commits the transaction by first writing to their log and then updating any data from the transaction. Finally, the subordinate node sends an ACK to the coordinator. If one or more nodes vote no, the coordinator writes an abort log and sends abort messages to each node. Upon receipt of an abort message, each node writes an abort log, releases any logs held, and sends an ACK to the coordinator. After the coordinator receives ACK messages from each node, it writes an end log and can remove any references to the transaction from memory. That is, forgetting the transaction. So here's the prepare phase pictorially. So you have coordinator, which is sending prepare messages, and then the subordinates, which are responding with yes. So overall it shows the flows of messages during the prepare phase from the point of view of the coordinator. To start the transaction, the coordinator sends a prepare message to each subordinate in the transaction. And here's subordinate prepare, and they say a yes vote. So as we can see from the sequence diagram, so coordinator sends a prepare to a subordinate, the subordinate writes a prepare log and then responds with a yes vote. This figure shows a similar flow of messages for a subordinate voting not to participate in the transaction. In this case, the subordinate writes an abort log to durable storage and sends a no message to the coordinate. The subordinate is allowed to release all logs and forget any state about the transaction. It will never participate in the transaction after sending a no vote. After all subordinates have voted yes or no, the transaction enters the commit phase. So here in this figure, we see the flow of messages right after the coordinator has received at least one no vote and must abort the transaction. So as you can see, the coordinator sends a write abort log. And then it goes to the first, in the log, it writes the abort message, and then it sends an abort message to subordinates. The subordinates write the abort log in their respective logs and then sends an ACK to the coordinator. The coordinator first writes an abort log and then sends an abort message to each subordinate that did not already vote no. Upon receiving an abort message, the subordinate writes an abort log to durable storage and sends an ACK back to the coordinator. At this point, the subordinate can release all logs and forget about the transaction. After receiving all ACK messages, the coordinator writes an end log signaling that the transaction is complete. In this case, it was aborted. Here, all subordinates have voted yes and the transaction is committed. The coordinator first writes a commit log. After this write, the transaction is considered committed and cannot be rolled back. After writing the log, the coordinator sends a commit message to each subordinate, and each subordinate commits the transaction by writing a commit log and sending an ACK message back to the coordinator. At this point, the subordinate can update any data and releasing any logs. After receiving all ACK messages, the coordinator writes an end log signaling that the transaction is complete. To handle failures, it is assumed that a recovery process is running at each node in the cluster. When a failure happens, the recovery process reads the local write-ahead log and accumulates information about any running transaction in progress at the time of failure. If the recovery process on a coordinator node finds a transaction is in committing or aborting phase, the coordinator sends a commit or abort messages to any subordinates that have not acknowledged the transaction. If the recovery process on a subordinate node finds a transaction in the prepare phase, it periodically tries to contact the coordinator to find out how to resolve the transaction. Once the subordinate knows how to resolve the transaction, it proceeds as normal. This leaves the scenario when a subordinate fails. The subordinate asks the current state of the transaction from the coordinator. The coordinator has no information about the transaction. The paper details how, in this case, the correct response is to abort the transaction since the process crashed before receiving all the votes needed. By aborting the transaction, it could be retried if necessary. Presumed abort. In the standard two-phase commit protocol, the process aborts when a subordinate transaction fails and the coordinator does information about the transaction to know whether to commit or abort. Since this scenario always aborts, it is safe for the coordinator to immediately forget about the aborted transaction rather than require acts. Note that this is strictly a performance optimization. Presumed commit is analogous to presumed abort, except if no information about a transaction is available at the coordinator node. It is presumed that the transaction was a commit. In this case, acts are required for abort messages, but not for commit messages. This is for the optimization. We assume that commits are more frequent than aborts. The paper concludes that in all cases, presumed abort outperforms the standard two-phase commit protocol. The comparison between PA and PC is less clear-cut. If a transaction is read-only, then PA outperforms PC, yet for transaction with updates PC requires less ACK messages than PA.